My talk is going to be about the top list of securing developer workstations. This is a talk that I've held a couple of times before. I held it at JFocus earlier this year, and I've held it at some other conferences. It's sort of a, we're going to get into the story about how I derived this talk, or how this talk came to be. But we can start out first by seeing who am I, and let's see how this works. Does this work? No, I don't know. I'll just jump like that. So this is me. Oh, yeah, I tried it. But I'm not going to stand, well, you see, it's me in 2 times. I've been working at Truesec for about 3 years. We have a booth downstairs. Please come and say hi. I have a couple of colleagues here in the audience too, so say hi to them too. I usually introduce myself as a mediocre developer to not get anyone excited, and then when I actually do something amazing, people go like, woo! So, and also one of my strong suits is I know smart people, so I can point you to someone smarter than me. I've worked a lot with data recovery. That's what I did sort of like the first year at Truesec, which was really, really fun, like trying to dig down in hard drives and recover data and stuff like that. I did that for a while. I've done code reviews. I do code reviews. I've done code reviews in incidents and for customers. And then this talk, which derives from, I've done about 30 or so assessments of companies. So usually we get invited to companies and they ask us to look at what we have, and then we sort of help them to become more secure. So, and I did a bunch of those, so I've seen a lot of development environments. And when I talk about development environments, it's all from the first code written until it ends up into production, and the entire journey of that. So. I've done threat modeling for a couple of companies, and then the past year I've been working with coding for sort of environments that have high security standards, so to speak. So you have to code in certain ways and sign a bunch of NDAs and not talk about it. So, and then on my spare time I code Rust, I fly flight simulators, and I like to dive and travel. But that's me. And so Truesec, I have to have a slide about who we are, right? We're a company that was founded in 2005. We are expanding constantly. We have opened new offices just the past year in both Denmark and Finland. We operate on a global scale. We help companies all around the world with everything security related. So everything from data recovery to development to monitoring, you name it. We have no limitations. And then you see here some of the things that we do is offensive security, SOC, which is security monitoring of different environments. And we're constantly growing and always want to be bigger and help people with security, because we want a secure world, and hopefully we'll someday get it, maybe, don't know. I'm going to start out also with a disclaimer to say that all the numbers, everything I post, everything might not be 100% accurate. Please don't kill me, because it's an ever-changing world, remember that. And if something is bad or anything, go to Truesec and complain, don't come to me. But if there's anything good, please come to me. I'll appreciate that. And if you have something that is personally directed against me, please feel free to post it on Twitter, because I don't have it. So, fine. So, I did a code review, I think it was about a year ago, and we found some serious vulnerabilities, we found some problems, we explained to them the problems and the mitigations and everything. And one developer said, basically one project manager said to me basically this quote. She said, "Why would anyone want to do that?" And that was one of those things that got stuck in my head. It's like, well, usually you can always discuss why people want to do bad things. Is it politics? What is it motivated? But of course, the usual one is like profit and world domination. That's sort of like the big thing, right? So, but when we do code reviews and try to help people, the first thing we always have to do is we have to establish what our target, or actually, like, what's the how do you say, what is the company afraid of, right? So, are they afraid of losing their source code? Are they afraid of getting people getting access to their admin accounts? Are they afraid of malware, encryption, right? What's their biggest fears? Why are they not sleeping at night, right? So usually when we talk to them about all these things, and then we have to see who are their threats, right? So some of the threats, they can be just people trying out things, just trying to poke at systems, trying to see what can I not see, right? Other developers, we've had a couple of talks here today where we've talked about bad things, and then you developers go home and try bad things, right? You might go for instance, I don't like the digital system my kid's school has. Let's try some things against it, right? That's something. Or you could have, for us, we sell hacking as a service. We have a bunch of pen testers that you can hire, and we'll try to do things, right? And then you have professional hackers. You have the ransomware groups, which are organized as complete companies today, right? And then you have nation-state attacks. So we have to always talk to each other about talk to the companies and talk to you developers. What are you afraid of, and who might attack you, right? So for instance, if I work at a startup company, I might not have to have that large security on my personal computer. But if you work for, I don't know, a huge bank, and you have a lot of sensitive accounts and sensitive things, you might have a different type of security and different threat model, right? So when I talk about the top list of securing your developer workstations, you have to then also think about what kind of company am I working at, and what kind of threats are I susceptible for, right? So it's all about which level are you as a company and you as a developer should put your security standard at. Because you all can't go military grade and be afraid of nation states, right? Would China attack your computer? Don't know. Depends on what company you work for, okay? So, but we're going to get to the top list. We're just going to talk about a bit of numbers first. So this is some numbers from the Truesec threat report that we always publish once a year. This is numbers from the January threat report. There's going to be a new one probably next year, and so forth, right? And some of the numbers that you can see here is that ransomware and access harvesting is something that is still ongoing and one of the biggest threats, right? And ransomware is still hugely costly for society, right? And they usually have to get access to high credentials, and all you developers usually sit on high-value credentials or high-value accounts, right? So you most likely are potential targets for these types of things. So then some other numbers are which kind of sectors get ransomware. It's a spread, right? And then some money involvement, right? There's huge money in this business, right? In ransomware business. So it's not going to end soon, because as long as you can make a profit, people will continue doing it. So then. If you've read the little text about this talk, there's a number there that says that from compromised until full ransomware can take as short as 2 hours. So here's some numbers from where that comes from. I read the Microsoft, they released a report a month ago or something. Their number was the median time from breach until full was 1 hour and 42 minutes. So it's actually a bit faster than the 2 hours that I said. So they're getting better, right? All right, and when we say manual activities means that usually when you spray someone and you get someone to click on something, they get access to the network, right? Manual activities is when the ransomware group actually starts sitting by the computer and hops onto the network that they've gotten access to and start to move laterally and try to find the backups and the Active Directory server, etc., etc., etc. So, all right, and then full compromise. This is the where I've took the numbers. A huge part here, like less than 2 hours, 58%, right? Less than 2 hours, 76. They're getting faster, right? It's getting easier to find like like getting full control of the domain, right? All right. So, with that in mind, we now know who we're defending ourselves against, what we're afraid of, right? How much money is involved into this, okay? And what it is we need to protect ourselves from, okay? So, I'm gonna start like with the more complicated things, like the things I see more rarely, and then we're gonna work ourselves up to the easy things that you should fix today, okay? So the first things that we see is that I've seen on computers is there's a lack of isolation on your personal computer, right? So usually everything is run in this. Oh, I might be in the way. Sorry. There you go. There's a lack of isolation internally in your computer. You just run everything just straight on. So one way to solve this is to run different things in different VMs. So depending on, you might have one VM for things that you want to keep securely, and then another VM for something else. Some things might be on the host, and some things, you do certain things in certain VMs, right? Another thing is that that I haven't seen, but is a really cool feature, is that VS Code, for those that use VS Code, is that you can use VS Code containers, which means that you code and run your code in a Docker container behind the scenes, right? If you trust Microsoft, they will provide you with different types of containers, with different runtimes, and then also what is one of the cool features in that is that if you run plugins, you can have separate plugins which will run, the plugins itself will run in the container. So they are also isolated from the rest of the system. Firefox, for instance, they have a plugin to Firefox which will run each tab in different container groups. So you can have more isolation between your tabs, right? So you can do your secure stuff in one tab and get additional security that way. So GitHub is out with code spaces, which means you can code remotely, right? And don't code on your own personal computer, and then remote VMs that you remote in and do your code on a secure VM in a network, etc., etc. So this is one of like the things that is very common to see, that there's a lack of isolation. Once you gain control of a computer, you have basically full control of the entire computer and everything with it, right? Okay. Another thing that we don't see, which is sort of like just as purely a health check, is that we see companies that don't have policies for using a computer outside of work, right? There's no policy for it. You go into the web browser history and you see the kids have been watching YouTube, and they've been browsing on funky sites. We've seen people that installed games for their kids on the computer, so the kids can play Fortnite, and so forth, right? Also, there's a hardware like where they bring their computer, where they leave their computer. For instance, if you leave your computer, most people don't know this, that if you leave your computer at the gym and the gym locker gets cracked and stolen, the insurance companies will not reimburse you. It's in every policy. Also, if your computer gets stolen from a car, they won't reimburse you either, because they are so-called high-value environments where people steal a lot of things. So you won't get reimbursed, and then the companies usually don't have like policies of how they're going to handle this, right? So, and also there's usually no policy of are you allowed to connect to public Wi-Fi's with your personal computer? People just go into the coffee shop and then connect, etc., etc., etc. So this is something we point out, that these are can be dangerous environments, and you have to have some sort of policy of how you handle your hardware outside of work. And this is something you as developers, if your company doesn't have it, you need to think about this, okay? All right. Another thing which is super common is this one, which is also not enabling disk encryption, right? So today, BitLocker is mandatory on Windows, right? So it's basically turned on by default. File Vault on Mac is not turned on, so please use it. If you don't, please do it. Well, Linux doesn't have it per default either, right? One thing that people usually don't understand is that disk encryption only works when the computer is turned off. When your computer is on, disk encryption doesn't do anything, right? So when you move from point A to point B with your computer, please power it off completely, right? Don't just shut it down and walk away, because then when it gets stolen, the disk is basically unencrypted, right? It's already, the keys are loaded into memory and everything. One thing to know is that there are certain types of attack called boot attacks. So when you boot your computer from cold, you can intercept the key and get it in certain circumstances. So this is not a 100% bulletproof thing, but it protects you usually if someone like tries to move the hard drive from one computer to another, right? And try to mount it and stuff like that, right? But there are certain ways you can get around this. But also, it's all about who are you protecting yourself. If a nation state would get your hard drive, well, they might get into it anyway. Right? All right. So now we've gone through some of the things. Now we're going to move on to the things where people are usually just naive. Okay. So they don't think about it, these things. This is just, I'm just going to go through these things and sort of like point them out that you have to think about these things. So this is a typical one. Too many IDE plugins. Every time we use something, if you've used VS Code, I don't know how many times VS Code has said, oh, by the way, there's a plugin for that. Oh yeah, there's a plugin for that. Yeah, so everything you do in VS Code, apparently there's a plugin for that, right? And you have to remember that we are inviting other people into our system. Their code will get run in your system, right? That's super, super important. Do you trust the people's code that you run on your system? Do you know them? Do you invite them over for barbecue? No, probably not, right? Snyk, which is a huge security company, they did a couple of reviews of some of the more popular plugins that got downloaded but weren't like made from a reputable company, like people that just wrote some plugins, like individuals. And they found numerous security vulnerabilities in those. For instance, there were cross-site scripting problems and other things, right? And they were huge plugins. I've mentioned some of them. They have a great article where they took some of the biggest ones and found security issues in those. So that's one of the things I want developers to understand, that you should review which plugins you have installed, do it often, and uninstall those that you don't use, right? Because there's a bunch of times we find people that have tons of plugins that I haven't used for very long, right? And a lot of outdated plugins, and then plugins which mainly are never updated. They're dead. Worth mentioning is also that if you provide a plugin to Microsoft, all they do is a virus scan on it. They do nothing else. Nothing. They just check that there's no like inherent virus in it that they know about, right? And there's an open issue on the VS Code GitHub, which people have demanded that they can put up local marketplaces, so they can just have a curated set of plugins. That issue has been open for 5 years and has not come to fruition yet. I still go in every once in a while to see if is it released yet? No. Is it released yet? No. Because right now, all VS Code basically go to the general marketplace, and then you have access to everything, and it's just a click away, right? So that's why that security, part of security, must be placed on the developers, because that can't be sort of, we can cut internet access to your VS Code, but that's not a good solution. So, right, let's move on to the next thing. What is something we developers like using? Well, package managers. Package managers is something which makes our lives easier, right? Just write a command and we'll install something, right? You have to remember once again, anyone can upload a package, right? For instance, we can say brew, which a lot of Mac users use. Brew basically doesn't check the origin of the package at all. So there's a lot of packages in Brew which are not maintained by the actual developer of that said software. Anyone can basically supply a package to Brew and say, please deliver this, right? Winget, which is the new Windows packet manager, they got, I think it was about a year ago, they went full release 1.0, and Winget got flooded with thousands of GitHub pull requests for new packages, which basically was name mangling. They tried to put in malicious software, switching names and providing other things. They basically got flooded. And Windows themselves, they were naive and said, no, we're just going to automate that process and let the PRs get accepted automatically. And after that weekend, when they got completely flooded, they had to back down and said, well, we might have to do some manual reviews of this instead. So they have to manually go through all packages and see if they're valid, right? Linux has stronger security with keys, and you have to verify the signature of the package, which is better. It's a lot better. That's why it's more well established to use packet managers in the Linux community. And then sometimes you also have to accept that you don't want to be on the latest and greatest and do updates manually when you want to. But there's a balance there, because if there's security issues, you want to have the latest and greatest, right? So, but then there's also things to be gained, like by not having the latest and greatest, because then you might end up in having like unsecure software, right? For instance, sometimes we choose to use, for instance, Debian as a Linux system, because Debian is a more stable and not having the latest and greatest, but still getting security patches, right? But packet managers are a convenience, but we need to understand where the packages are coming from, which many people usually don't understand. Another thing is, of course, one of the big elephants in the room is the third-party dependencies, right? I love this image. This is a piece of art. I love that image. And can anyone guess what this is? Except for my colleagues, because they know. So, does anyone know what this is? No, well, we'll get close. Not NPM, was someone who said. Yeah, sort of. This is a React. So for all you fabulous front-enders, this is React scripts, basically the thing that runs React in the background, right? It has a couple of dependencies, just a couple, right? There's a cool, Google has a pretty cool tool that you can basically select packages, and then it will give you this amazing graph image, so you can see how terrible some packages are. And React is, you get a piece of art, which is, I'd like to frame that. So, but once again, we're inviting people into our system. Like, here's a piece of code, please run it, right? So every time you develop, this is something we use all the time to, of course, to have faster development times and stuff like that, but we have to also understand what it is we're pulling in, what are we actually running. So, for instance, I've put this as an example. UR parser had a crypto miner and password stealer, so it was basically targeted to developers. It didn't care if you run it in an application, because there's no valid. It had like, it tried to steal things, personal wallets and things from people on personal computers. If you run it in a server, it didn't really care. It targeted people, right? And so there are dangerous things, and a couple of my colleagues are really good at third-party dependencies, and so I'm not going to talk that much about that, but come by the booth and ask about third-party dependencies and you'll get a lecture. And this is on the rise. Insecure third-party dependencies is a huge security risk at the moment. All right, now we're starting to get to the things that everyone is usually aware of, and that's why it says you all know what's coming here, right? So now we're getting to like the top ones. What do you think is going to be in the top ones, right? We can start out with this one. This is something everyone goes nagging about, right? This is like, so let's do the question. How many here has MFA active on everything? Right? But most things then, most things, okay? Well, that's pretty much, right? Who doesn't have MFA at all? Does anyone, is there, okay, there's one. Great, kill him. No, sorry. No. Everything that this is not a recommendation. This is an order, right? Everything that is publicly facing and publicly accessible must have MFA. That's one of the things we tell developers, customers, everything. Everything that is accessible from the internet, logging in, needs MFA. There's no discussion. I won't bend. I'll fight you for it, right? Right? Everything internal should have MFA. That's a recommendation that we say if you have like GitHub internal or something like that, we do still recommend people using MFA internally because you can't rely on just your wall as a protection. VPN solutions must have MFA. We still see companies having, especially like when the pandemic started, people rushed in to get VPN solutions in place and no MFA, right? So, and also something that we point out is that SSO is a risk, single sign-on. Single sign-on is a risk because if you get an access to one place, you suddenly have access to multiple places at once. So there is a huge risk. It's a very nice, convenient thing to have, but sometimes it's convenience and security doesn't always go well together. Right? And then there's different types of MFA, which not everyone is usually aware of. You have like the regular one that most people use is either you just approve in the app, but we want something like challenge and responses. For instance, many of you have seen you punch in the code that you have in your MFA application, but then you can also have like, for instance, the server can send you out the question that you need to ask. It shows a number on the screen and you get a selection of numbers in your app and then you pick the correct answer, right? Because we want human interaction between you and the computer, so we want some type of challenge and response. So we also enforce companies that don't just use the approval of a click on a phone, right? Approve, right? Then the next thing, which is also an elephant in the room, and here I usually end up in discussions and fights, so fight me again, no. Admins everywhere. Admins. Oh, we want to be admin. But yeah, as people usually say, they go like, oh, there's an app for that. Well, I need to be admin to do that. I need to be admin to that. And I always go, really? Do you? Well, it's convenient, right? Admin is dangerous, and I'm going to as we say, admin is actually dangerous. But the problem is we don't usually ask for things that are not run as admin. We get something and then the application says, I need to be run as admin, and then you go like, okay, and then you move on with your life, right? Except for instance, when Docker came and people saw this is dangerous, and then they say, okay, fine, we'll provide you with a Docker that doesn't run as root. But that's when we asked for it, right? We don't ask for security, and then the developers won't give us things with security. So that's one of the reasons I preach, because I want all of you in the room to run to different vendors and tell them I don't want to run as admin. I don't want to run things as admin, because I sleep better at night if I don't run things as admin. But sometimes you still have to, right? If you need to run things as admin, we encourage you to just run admin for that particular task. Right, so you just elevate, you do what you want, and then go back to your regular life, right? Or have time-based, like if you work with some sort of system, you should try to fix that you only have access to that system for a particular time, right? There are certain systems that have that feature, but we need to push on vendors and push on applications that you want to run things at a lower how do you say, authorization level. So think about this. Don't run as admin all day long, please. Right? Another problem that we also see when we're coming is this, the too much access problem, right? If you work at a certain company for a certain period of time, you accumulate accesses. You collect them. That's why I have this. It's like you have to catch them all. And not until I have admin all over the place, that's when I feel complete, right? A question that I can ask many people are, when was the last time you actually contacted someone and said you want to revoke your access from something? And I'm saying quitting the job does not count. So, right? So we need to be a lot better at thinking about what do I have access to and do I actually need it? I prefer having as little access as possible because then I sleep better at night. And if something goes wrong, I can point at someone else and say, it wasn't me. Oh, the company got ransomware. Well, it wasn't me. I didn't have access to that system. But I think you as a developer, you should review your accesses to external systems on a regular basis. So you should think about, oh, I haven't logged into that system for quite a while. Well, maybe I should ask to get removed. Because you never know, right? If someone gets my stuff, something bad might happen. And then we're going to go into the biggest elephant in the room. You all know what it is. What's the biggest elephant in the room? Human factor, nah. There we go. Passwords. Oh, we love these, right? Yeah. It is still the biggest problem. Without a doubt, biggest problems. Weak passwords is massive problem, right? Microsoft's threat report that I read the other day said that they saw across their security solutions monitoring systems, they saw about 950 password logon attempts from malicious people 950 times a second. So people try to use passwords everywhere and try to log on to things, and this is the biggest problems. Harvest credentials, harvesting different hashes and NTLM hashes and trying to crack them because people have weak passwords, right? It's the biggest problem. We have a recommendation. The last time I checked, this was our recommendation: 17 characters and at least from 3 different character groups. And when we talk character groups, we talk small letters, big letters, weird letters, exclamation marks, etc., and numbers. So you pick 3 of them at least, right? And 17 characters. But as I've written here, to be honest, if you have a password manager, why not go 40? Why not go 50, right? I have a couple of colleagues that got mad at a couple of systems because they have such long passwords that that particular service or something truncates their passwords, right? It's happened, right? So that's why I want my 256 character password, please, right? No, but to be honest, I'm assuming that everyone in here uses password managers, because otherwise fight me. No, but please. And also, something which is on the rise is using hardware keys, right? We have YubiKeys, which is a great thing to use, hardware keys. Smart cards, which actually is in use in certain places, right? Or just avoid them, please. And not saying that you should go like, I'm not going to set a password at all, as in avoiding. I mean, use keys instead, SSH keys, etc. So you don't have to like deal with passwords, right? So that's sort of like the main gist of it all, and that is the completed top list. So I'm going to end you with a quote from the Microsoft threat report, and that is that today's hackers, they don't break in, they log on. That's what they do. There's no reason to break in anymore because that's what they do, and they usually succeed, right? Most of the numbers that I have that I've shown you here is from the threat intelligence report of 2022. It's written by these are some of my great colleagues that work in the threat intelligence department of Truesec. I highly recommend that you go to Truesec's webpage and download the report. It's super interesting. It has a first part section which talks about all the numbers and stuff, and then we have some curated cases of things that we have found during different incidents where we've described the MO of the attackers. So it's really interesting to read how the attackers do and what they do in systems and how they've gained access and things like that. So, but and then the main takeaway of this sort of talk is that the security is not the code we write or everything. You have to build a culture, as in talking to your colleagues and your mates and try to like build a sort of sense of security together. So that's sort of the main takeaway of this talk, that the security starts with you, and you can't always like rely on other things to do it for you, right? So that's about it. So feel free to contact me if you have any questions or anything, and come by the booth and say hi and eat some candy. So, thank you very much. Mm-hmm.